should give me a notice. Or not, maybe it won't. Okay. Usually it gives me a notice. That's okay. I can find it. Maybe that's it. Ah, there we are. Okay, so it seems to work. Log into okay, go to fall. I might as well open 7 anyway. So we are on 6? We're on 6, right?
I think so.
Okay.
Under the live video, I want to close 5
Oh, okay. So let me just do 1 or 2. Wait a minute, that's the same one. Except, oh, I know, I get it. And I think I sort of monkeyed around and did that one, maybe, online last week. There it is again. Maybe I should just go straight to that one. It's got the answers there. I think I'll just do that. Because this one will show kind of that concept. Let's see, Control S. Okay. I'll just go straight there. Straight to the meat of the issue. And then I need to start a new page. And I don't know, something's wrong with this screen. It's like at an angle or something. It's okay. I'll figure it out. Okay, so there's that picture. Next picture. Okay, Control this. There are 3 cables, a 40 kilogram flower pot, I guess. Okay, now I gotta get that out of there and draw red. So I'm gonna go straight to the thing that I was doing over on Friday and just do it that way. I know what you're supposed to do is you're supposed to sum forces in the X and the Z, all 3 equals 0. But I'm going to shortchange myself, and I'm going to sum forces of all 3 at once, equaling to that. And since I'm going to focus here on A, this is a good one to do that, because what I'm going to do, I'm going to find the unit vector. These are easy. These 3 are easy. And I'm going to call that F for flower pot. The unit F, the unit towards B, and then the unit towards C. This one's the hard one here. The unit vector towards D. Now, all right, I know this thing's 40, but I'm not going to kilograms yet, but I'm not going to carry it right now. I'm just going to, that's what its weight's going to be, but I'll do that in a minute. What I'm going to do is I'm going to jump straight into doing X, Y, okay. Oh, there's the mouse. With the control, I can make it go down. X, Y, and Z. And I apologize about doing it this way, but we'll do it this way and then go back and do it the more okay, how do I select all that? Oh, I can use the Alt key, that's right. Select all that junk. I'm going to move it down and to the right because I can write over the top of it. Now, I hate to do it this way, but I'm going to do it this way because actually there's a certain sort of ease in doing it this way. Unit vector, you can pick them at random. C, B, F, and unit vector D. That looks like a D. And I'm going to list them here, and then I'm going to write them out, and you'll find out that they in fact are the sum of the forces in the X, Y, Z. Either way you like it. So the unit vector in C, okay, so I have to pay close attention. It just goes like that, meaning the unit vector in C is equal to 1i plus 0j plus 0k. Unit vector in B goes in the positive y, so it's this. The unit vector in F, okay, Z should point straight up, so the F points straight down. This is a very odd way to do it. Now here's the hard one. The hard one is that I have a rope that goes from A to D. If I wanted to list it, it goes from A to D. This is R, A, D. It runs backwards 1.5 in the X. It runs backwards 2 in the Y. It runs up 1.5. Why am I listing them? Sorry. Okay. Alt. Hit the Alt. Hit the eraser. Hit the Alt. It's supposed to be I and J. Sorry about that. That's the I, J, K components. If I want to know the unit vector, which points to D, over the unit vector A to D. Now, I know this is weird. Okay, now, but bear with me and I'll back it out. I'll create the matrix this way and then come back and show you that in fact this is some of the forces in the X, Y, Z. But give me a minute. I don't know where this is. Oh, gosh. Okay. Uh-oh. I may have done something. What did I do? I guess I'm okay. Oh, there we go. Okay, so RAD is equal to minus 1.5 minus 2 and 1.5. And I get, oops, somehow I ended up, oh, the period is right by the comma. So let's see, make sure that's right. Minus 1.5, minus 2. And I meant to call it RAD, not TAD. Okay, so there's RAD. Now if I want to find the unit vector going towards the D from A, it would be equal to RAD divided by the norm of RAD. Gives me those numbers. Now, let's see. Just out of curiosity, what is the length of that rope? I'm just thinking, if that is an integer, nope, that's not an integer. Well, okay, so I'm just going to go with that. So I'm going to copy it just so I don't have to copy it again. Control C, this thing, okay. I'm going to just sort of put it right there maybe. This is not a touch screen. Let's see, I'll move it to the right. Apparently I don't. Let's see. Come on, man. This is ancient technology here. Okay, so that unit vector is minus 0.5145i minus 0.6860j plus 0.5145k. So all it is that vector divided by its own length. So I like to also check and make sure that the unit vector is the unit vector. Oh, and apparently it is. So what I'm going to do now is kind of weird. 5145 minus 0.66. That's a 0.68605145. Now, this is really strange, but I'm going to show you in a minute that this notation always works, and it's very strange, but okay, so I'm going to say this is the tension in cable. Okay, it's originating at A, so I'm going to say AC. The tension in cable AB, tension in cable AF for the flower pot, tension in AD. So what I'm doing, these should line up with those. And that's kind of a standard, because that's how we do the multiplication, and we'll do that in a second. But here, now, I know some people don't like matrices, but if you get used to them, they make your life really easy. So what I have is 3 rows by 4 columns, and that's right there. This thing, 4 rows by 1 column, yeah. And so these cancel out, and so what you end up with is a 3 by 1. And 0, 0, 0. So in fact, this thing ends up being sum of the forces in the x equals 0, sum of the forces in the y equals 0, sum of the forces in the z equals 0. So what I'm going to do is multiply it all out, that matrix up there, and maybe I'll solve it, and then I'll go back and multiply it out. So if I were to run over and solve this thing, the first thing I would know is I would know the tension in that flower pot. Reason being, it told me the flower pot weighed or had a mass of 40 kilograms. So if I did 40 kilograms times 9.81, 392.4. That sounds good enough. 392.4. So, oops, I didn't close that. So technically, what I should do is this. I should go in here. Come on. I should go in here and scratch that out and say I know the tension there. Tension's 392.4. And that doesn't look like, but that's a 9. So if I start, I'm going to go ahead and erase this junk here. Now I'm going to go through and multiply all this out just because I said it was. Here, delete, I guess. Okay, so if I multiply this out, what I've got to do is I can erase this in a second. So I multiply this times that, plus this times that, plus this times that, plus this number times that one. That will be the first one, and the first one row will be the X. So now I can go through, let's see, I'll take those off. And then what I'll have is TAC. Nothing comes from the other two. Nothing comes from here or here. And then I get minus 0.5145 times 392.4 equals 0. Now, I'm going to go ahead and stop and try to see if I can calculate this. Oh, wait a minute. You know what? I made a mistake. That is not the flower pot right there. This is the flower pot. Okay, so let me fix that. Okay, let me get the eraser in here and start slowly getting Alright. Sorry about that. So this is the flower pot, not the other one. That's the flower pot. So that is the 392. That is the 392.4. So in fact, I'm wrong, and that shouldn't be there. I was about to say that can't be that easy, but that is TAD equals 0. So if you look at this, let's stare at this one for a second and just say, is this the X equation? Well, TAC, if you look at TAC, that is this one, and that is in fact going in the X direction. Then the other part is that you should get something from this cable D, because this cable D is the only thing that goes in all three directions. So you get the component going backwards in this direction, which is 1.5 divided by the magnitude of this thing, which was 1.5 squared plus 1.5 squared plus 2 squared. So I'm going to check that out and figure out what that component is to make sure my coefficient's right. Hopefully I'm making sense here. Alt. Okay. 1.5 divided by square root. Now I could do the norm, but I'm doing it the long way. 1.5 squared plus 1.5 squared plus 2 squared, or 4. Oh, I thought I hit enter. 0.5145. So is that number 0.5145? And it is. And it's minus because it's going in the opposite direction. So that, in fact, is the x equation. Then you go in here and look at the second equation. Well, the second equation is this. Oops, hang on. It's this one times that, plus this one times that, plus this one, which actually is the flower pot, times that, plus this one times that. If you look at the right-hand side, it all has to equal 0. So here, let me take all those off. Ooh. Oh. Okay, I don't know what I did there. So, look at this thing. It's TAB minus 0.686 TAD equals 0. That makes sense. This should be the y equation. So let's say if TAB runs only in the y direction, and it does, TAB runs right along in here, and there's a component heading back this way that comes from this cable. And that component is, believe it or not, instead of 1.5, it's 2. So if I go back to MATLAB, okay, Alt Tab, and then hit that, go up here and put a 2. That's the number I should have down there. 686 is what I should have. And that's what I've got, 686. Now the fun one is the z direction, because it actually has that times that plus that times that. Now, of course, it has the others as well, but they have 0. So what you get is minus 392.4, which is actually TA towards the flower pot, plus 5145, which notice that and that are the same number, but they're not in the same direction. That's because they're both 1.5. In other words, that's 1.5, and so is that. And TAD equals 0. So in fact, that's the z equation. And these equations are, just simply, I should say it this way. Sum of the forces in the x equals 0. Sum of the forces in the y equals 0. And sum of the forces in the z equals 0. Now, I don't think I put the matrix in there yet, but to me, since I can operate kind of off MATLAB, I'll just do this. What I will do in MATLAB is I'm going to take this, move it to the right-hand side. It will change signs. I'm going to put this as column 1, this is column 2, and this is column 3. But if I move this to the right-hand side, the reason I'm doing that is because all these numbers get moved over times 392. Let me write this again, and I'll show you what I mean. So in other words, this whole thing could be written this way. Okay, it's easy. 1, 0, 0, 1, 0, 0. And then minus 5145 minus 0.6860, 0.5145. But this is multiplied times everything except that one sitting here. TAC, TAB, and TAD. Now, technically, I've left something behind. And what I've left behind, why does it not let me move to the right? If I do a right arrow, it goes down. Maybe if I right that way. There we go. Okay. But I don't have a pen now. So technically, I could say that's TAF times equals to 0, 0, 0. And I forgot those numbers, but I think it was a Z. Yeah. 0, 0, minus 1. So you have to stare at this for a minute, but this is the same thing as that matrix there. It's just I extracted one element out of it, and the reason I did that is because that value is 392.4, which means I can multiply this times that. I'm sorry, that should be a plus. And then I could move it to the right-hand side. So what I'll end up with is a matrix that looks like this. 0 minus 5145 minus 0.6860, 0.5145, TAC, TAB, TAD, and that's got to equal to 0, 0, 392.4, because that's the weight of the flower plot. Now I have to take the time to go put that in. I'll call it a K matrix, and I don't think I did it yet. Minus 0.545145, 0, 1, minus 6860, 0, 0, 5145. Stare at it a minute, make sure I copied it in there right. I think it's okay. And then my right-hand side is supposed to look like, I don't see it anymore, but yeah, I can scroll down right there. Nope, I can't. Okay. Okay, hang on. Uh-oh, I got two equal signs. 0, 0, 392.4. Now, I can just type in inverse K times the right-hand side. And I'm not going to copy those back and forth, but I am going to just drop them down here somewhere. Oh, geez. Okay, so, good grief. Why did I copy them so small? So TAC equals to, TAB equals to, and TAD equals to. Yeah. So this is 392.4, which that's odd. I can barely read that. So I'm going to zoom in. 523.2 and 762.7 roughly. I have to go look and see if I got the right answer. Let's see. Okay, now I've got mine listed in a different order. I'll tell you what, let's do it this way. Control. Okay, wait a minute. Oh, shoot. Okay. All right. just see if I can put it right there. He called his F, I called mine T for tension. So FAD is my TAD. 760, well, I guess if you got rid of that. FAC, yeah, if you truncated that, and then 523. So it looks like in the book he's using everything with F. I guess I should do that too, but I keep thinking that T is for tension, so, you know. This is a very odd way of doing it, but if you're comfortable with the matrices, the dang thing always works. So if you just list the vertical, you know, you can list them other ways. I mean, you can actually list the y equation before the x, and I think I did that by mistake in one of the lectures. I think I may have done that Friday. But if you want to be systematic, you could list x, y, z, and then just list the base vectors of all the connections to your center point. Then make sure that this list that goes down here follows the list here, you know, because TAC, because if you look at it symbolically, what you got is TAC times UC plus TAB times UB plus tension of the flower pot, UF, and notice these are vectors, and if I can slide it one more to the right, plus the value of the tension in AD times UD, and that all equals to, and it's supposed to be a zero vector. So that, in fact, is kind of the vector form of sum of the forces equals to that, where x, y, and z are listed in there. So that's the reason I do that. It's because they all, if you do these problems over and over and over, especially for 10, 20 years or so, you can do them over and over for a week and you'll see the same thing. But that always works. Doesn't matter what it is. At this point, you got this. There's no description at this point whether that's two-dimensional or three-dimensional. If it's three-dimensional, you'll have three of those equations, which means that you'll have an x and a y and a z. But if it's two-dimensional, you'll only have two. And it's that simple. So you can do these problems over and over and over, but they always have that same pattern. I don't even know what time is it. 11:39. So is that I don't know. Seems like an okay way to work it to me. I mean, I can come back in next time and I can do those other two that are two-dimensional. Well, that's no fun. Well, okay. We'll do that one, because that one next time, what we'll do is, we notice we have two sets. So on that one, you'll have an equation around B and then an equation around A. And what we'll do is we'll come in, I'll list it the shorthand way. I'll pick one of them, maybe I'll pick A first, do it, and then I'll do B, set up the matrix, and what you'll find out is kind of interesting. Of course, A and B, the tension in there is the same whether you're looking at ring A or ring B. So that's all you got to do. So I think that's what we'll do. We'll do that next time. And then what was after that problem? Okay, there's a three-dimensional problem. That's a different three-dimensional problem. That one has a few more angles. So I'll set that one up next time. And then, it's just the same problem, except, now that's interesting, it's symmetric about the, x-axis there. That makes sense. FAC and FAD should be the same. Unless you moved one of those out, but they're both at 2 meters. So, there you go. Another day, another dollar. If you're lucky. You want me to go ahead and open the next week too? Might as well. If I can figure out how to do it. Okay, wait a minute. Content. I'll just go ahead and open the next week. So I opened 7. I'll go ahead and open 8 and 9 too. All right. So I'm going to call it good. We'll come back and do 2 problems tomorrow. Day after tomorrow. Now I got to go figure out how to struggle through fluids with nothing set up. Uh-oh.